right, so today we're going to be talking about vertical and horizontal asymptotes, and this is different than day one because day one had an A, H, and K, and all of these examples that we are going to have do not have a specific H, nor do they have a K value, but they are still going to look like rational functions with the curves and all kinds of, they are going to make a little bit of extra things sometimes. So they are still going to have asymptotes. There's got to be a way for us to be able to still find these asymptotes without the use of A, H, and K. So let's first talk about vertical asymptotes. Vertical asymptotes, where did we find them before? We found them in the denominator because it was H. We are still going to find them in the denominator. Our vertical asymptotes are still based on what makes the denominator 0. So we are still going to find them in the denominator. And our steps, we have two of them. We are first going to factor the denominator if we need to. Sometimes we don't need to. So sometimes it requires GCF, sometimes it requires factoring trinomials, sometimes it requires both. So first step is to factor the denominator. The second step is to set those factors equal to 0, and that is what's going to give us our vertical asymptotes. So this first example that I have is x minus 4. In the denominator, I set, that's already factored. So I set that equal to 0, and my vertical asymptote is x equals 4. This last example up top, because it's a little easier, all I have is x there, so my x, my vertical asymptote would be 0. This middle one's a little bit more tricky because it's got a trinomial. More importantly, what's involved in that trinomial first is it's got a 2 in front of everything. Everything's even, so I'm going to divide everything by a 2. But then I also don't like that it's a negative in front, so I'm going to divide everything by a negative 2, which leaves me with x squared plus x minus 6. That is easier for me to factor. So two numbers that multiply together to give me negative 6, but then add to be positive 1 would be a positive 3, so x plus 3, and then negative 2, so x minus 2. Set those factors equal to 0, which means x equals negative 3 and x equals 2. So now what I'm going to do is I'm going to show you what these graphs look like in Desmos so you can see what they're doing, so you can see what these asymptotes are doing, and see that while these look different than the A, H, and K's that we equation-wise, graphically, for the most part, they're going to look the same. So this first one, x minus 3 over x minus negative x plus 3 over x minus 4. I have that asymptote at, I have that vertical asymptote at 4, which we found. This next one, x minus 3, negative x minus 3 over x is going to have a vertical asymptote at 0. You'll notice it does still have a horizontal asymptote, and it looks like it's going to be a negative 1, and we'll talk about where that negative 1 horizontal asymptote is going to come to in just a second when we talk about horizontal asymptotes. Then this last one is the weird one. I had two vertical asymptotes, and I'm allowed to have 2. I'm allowed to have 3. I'm allowed to have 4. We're only going to get to 2, but this, you are allowed to have 2 vertical asymptotes, and so it's going to do this really interesting thing. It's still corners. If you kind of think about it in halfwise, like it's still corners, but because I have 2 of them, I now don't have just corners, I have a little bit more. So I have a curve here, I have a U thing happening in the middle, and then I have a curve over there. So it does some really interesting things when you start getting some trinomials down there in the bottom and getting more vertical asymptotes. It does some really interesting things. So now let's talk about horizontal asymptotes and where we find horizontal asymptotes. And there's a great mnemonic that I did not create called BOBO, BOTN, EATSDC. And it stands for certain things. So BOBO is going to stand for bigger on bottom. Your horizontal asymptote is going to be 0. And we don't know what bigger is, what we're talking about being bigger. We'll get to those examples in just a second. But for right now, just know that BOBO stands for bigger on bottom. BOTN is going to stand for bigger on top. Bigger on top means that you have no horizontal asymptote. What you actually have is a slant or oblique asymptote, which will get covered in pre-cal. And then you have exponents are the same, EATSDC, EATS, exponents are the same, DC, you're going to divide. So that is what BOBO, BOTN, EATSDC is. It's a great mnemonic to remember these. So vertical asymptote is your denominator, horizontal asymptotes is BOBO, BOTN, EATSDC. So now let's look at the 3 examples in our notes, and then we'll talk about first I'm going to say just which ones they are and then talk about what is it I'm talking about when I'm talking about BOBO, BOTN, EATSDC. This first one is a BOBO, the middle one is a BOTN, this last one is an EATSDC. So what is it I am talking about? If you look at this first one, bigger on bottom, what is bigger on bottom? It could be that there are more terms, and that is really true for all of them. There are more terms in that middle one, and there's an equal amount of terms in that last one, but that's not what we're talking about. We're not talking about terms. So what else is bigger on bottom on this first one? And what we're talking about bigger on bottom is my exponents, or my degree. My degree is bigger on bottom on this first one. I have a degree 2 and I have a degree 0 on that top. So this first one is a BOBO, bigger on bottom. My degree is bigger on bottom. It's really Bob 0. So that means my horizontal asymptote is 0. This middle one is a BOTN. I have a degree 3 on top. I have a degree 2 on bottom. Bigger on top means I have no horizontal asymptote. What I actually have is a slant asymptote. And I am going to show you guys these on Desmos so that you can see that what these look like. This last one is an EATSDC. My exponents are the same. Squared and squared. My largest exponents are the same. So then you're going to divide your coefficients. So my coefficients are those numbers in front of those exponents. So I have a -2 and a 1. -2 divided by 1 gives me -2, so my horizontal asymptote is -2. Pretty easy. So now let's go and I'm going to show you what these look like graphically. This first one actually had a typo in the notes. It was supposed to be 3x squared minus 27. Plus 27 does not look right. So this one is supposed to be minus 27. So you have that horizontal asymptote at 0. I also have the 2 vertical asymptotes, which makes sense. This next one is my bigger on top. So this next one, bigger on top, means I would have no horizontal asymptote, and you can see I don't. There's no horizontal line that they all follow. There is a slant line, a slanted line on there that they are following. At least the curves are following, and that's what's happening with this one. We are not going to be responsible for finding slant asymptotes. Again, that is a pre-cal topic. And this last one is my EATSDC. Exponents are the same, squared and squared. I divided my coefficients, so that gave me a horizontal asymptote of -2, and you can see my ends are respecting that horizontal asymptote at -2. All right, and those are the notes. Now, I do have 3 additional examples that we were doing in class to kind of help you maybe concrete this into our brains. So I have these 3, and we're finding vertical and horizontal asymptotes. Now, it is easier to find horizontal asymptotes first because horizontal asymptotes are easier to be found non-factored. It is hard to see what is the degree if you have factors, and it's a lot harder to find coefficients if it's already factored. So if it's in standard form, it is easier to find your horizontal asymptotes because that's your BOBO, BOTN, EATSDC. Vertical asymptotes, you got to factor it. So before we factor it, let's find our horizontal asymptotes. So this first one is a BOBO, bigger on bottom, because I have a squared on the bottom. So bigger on bottom means my horizontal asymptote is 0. This middle one is a bigger on top. I have the squared and a 1. Bigger on top, no horizontal asymptote. And this last one, I have a squared and a squared. It's an EATSDC, so I have 1 over -3. So my horizontal asymptote is y equals -1/3. Then vertical asymptotes, you do have to factor it. So I'm going to factor this first one. 2 terms should immediately be thinking GCF. So I have a GCF of an x. So x, dividing both terms by x, and I get x plus 3. Set each of those factors equal to 0. So that means my vertical asymptote is 0 and -3. So I have 2 of them. That's okay. This one, there's no factoring to be done. I set that equal to 0. -4x is equal to 0. Divide by -4. 0 divided by -4 is still going to give me 0. So my vertical asymptote on that middle one is 0. And this last one, I'm going to factor it. I see a 3, and I see a 3 can go into all of those, but then I really don't like that negative. So I'm going to take a negative 3 out of everything, which is going to give me x squared minus 2x plus 3. Only one way to get 3, and that's 1 and 3. Negative 3 plus 1 is going to give me the negative 2, and then I set each of those equal to 0, so I get x equals 3 and x equals negative 1. And those are my vertical asymptotes. That negative 3 is not affecting my factors. So that negative 3 is not going to change my asymptotes. My asymptotes are 100% dependent on my factors, and my factors are not affected by that GCF. If I were to plug in some numbers, that GCF being negative 3, if I were to plug in some numbers, yes, I would have to multiply those numbers by negative 3. It is doing something to values, but it is not doing anything to my asymptotes. My asymptotes are what's going to make that 0, and what's going to make that 0 is 3 and negative 1. And that is asymptotes. Next class, we're going to be talking about graph holes, which involves some of this as well. So